take a moment now to have a look in the application note where we have block 302, which defines paths for master in, slave out, master out, slave in, chip select, clock, interrupt, which in this app note we're ignoring, and an SPI initialization, which sets up the I/O lines in the correct initialized state. Also have a quick look at block 304 at two of the low-level routines, 1 bit in and 1 bit out, which are the low-level routines that send a bit out, a master out, slave in, and 1 bit in, where we read 1 bit from master in, slave out. These words are used later in a loop as well when we're adjusting the clock in order to do a full transfer. This is a snippet of code taken from block 305, which is fully listed in the application note, which has several and very important words in it. First, I'll go through the word that's responsible for transferring just a single bit of information. It transfers both an output bit and reads back an input bit. It's defined in block 305, which is in the app note. The routine is called 1 bit. It accepts 1 bit on the low order bit on input, and it sends that out, the master out, slave in line. It then clocks high, and then it reads a bit on the master in, slave out, and then returns the clock low. So this is the timing diagram. The clock is assumed and set up initially to be low. Then we execute clock high. The data in the meantime has been set up in the correct state before we do the transition. So the I/O, in this case the output, which is controlled by the master out, is set in the correct state, high or low. After the clock transition, the device has the correct data on its output line, which we then read, and then we return the clock to its low state, ready for the next transition, which later on will execute the 1 bit routine in a loop. For this particular device, the CMA 3000 will always loop 16 times and always do a full 16-bit transfer.